The fourth classification is based upon concentration. What is the fourth one? Based upon concentration. Okay. So here concentration is something is also divided into two again. What are these? Let's see. First one is the word itself. Concentrated assets. What is the first one, children? Concentrated assets. And the second one is dilute assets. What is the second one? Dilute assets. Well, how these are again divided? Why again so many assets classifications we are discussing about? Okay, we have to clearly classify the assets, okay, based upon their source, okay, based upon the molecular composition and also based upon their strength. And coming here is based upon their concentration. What is the concentration over here? You know, the main concentration of the word is based upon the amount of water present in it. You know what is mean water? Yes, H2O, the chemical formula H2O, based upon the amount of water present, and this concentration is again classified into again. What are those? Concentrated and dilute. And these importance you learn in your laboratories. If you come to higher classes, then you can understand why these again classify into two again. Concentrated acids and dilute acid. There is something difference between them. We'll see what is that. Okay, don't worry. So here we'll write the word. It is based upon amount of water present. Amount of water present, this particular concentration, okay, it's again classified into concentrated acids and dilute acids. Here is a representation of concentrated acids, children. In the laboratories, you can see on the label of the particular beaker. If you observe, it is written as like this: CONC dot acid. Some of the name of acid. Okay, concentrated acid. This is a shortcut and is the particular representation of concentrated acid. And coming with dilute is something small DIL dot the acid name. It may be some other acid. Okay, so this is the main representation of concentrated acids and dilute acids. Now, what are these concentrated acids? I don't understand till now. Okay, no worry. We'll see the clear definition and clear representation of the particular concentrated acid. Okay, so these concentrated acids are something which contain more amount of acid. Okay, let's say what is the word here? More amount of acid. Okay, fine, that's it, madam. No more. You said about water, something water is playing a major role, you said. Yes, here absolutely is something but water. And here with the more amount of acid, there is a very little amount of water is mixed. Okay, more acid and very little amount of water. And if we mix this particular two things, we call it as concentrated acids. What is it again? Concentrated acids, which means more acid with very little amount of water. What coming to dilute? You can also say here, opposite to that. Yes, less acid plus more water. Less acid plus more water. Thank you, ma, for the easy definition you gave me, Tolina. Okay, so this is an easy one too, because you can also write acids which contain more acid plus, yeah, acids which do contain more amount of acid with very little amount of water are called as concentrated acids. Okay, coming to here, dilute acids which contain less amount of acid with more amount of water are called as dilute acids. Like that also can be definition, but here I gave the easy representation to understand clearly. Okay, fine. So here more acid plus less amount of water. You can also use the word it is pure. Okay, this concentrated acid is pure because it's mixing with more amount of acid. No, we can also cite pure acid. Okay, so when an acid is mixed with very little amount of water, okay, that is called as concentrated acids. Once again, the more amount of acid is mixed with very little amount of water, and that is called as which acid? Concentrated acids. Okay, and what about dilute? Less amount of acid is mixed with more amount of water, plenty of water. Okay, that is all about dilute acids. Because why we have to do all these things in laboratory? There is a specific reasons and all. Okay, and here examples, if we go with the examples, just small representation. Okay, we can write if the acid CONC dot HCl means, yeah, HCl is having concentrated nature. Okay, And the same example we can write here also, which means HCl only, but before that we can write dilute, which means, yeah, less amount of acid, more amount of water molecules. Fine. So this is all about concentrated acids and dilute acids. Okay. So here a point to be noted here, children, which means you know the strength of acids plays a very major role in the determining strong and weak. Okay. But what about this concentrated and what about this dilute? Are these are also coming under strength? Okay. If I say concentrated acids are very strong, can I say the word concentrated very strong? Okay. Maybe or may not be. Can I say dilutes are very weak? We can't determine based upon the strength, because why? These two are classified based upon only called as concentration. Okay, you should not mix each particular classification of acid into any other type. Okay, you should not mix anywhere. And here if I mention the note point here over is note to be considered. Okay, so this concentration is based upon acids into concentrated and dilute. It doesn't mean upon the, it doesn't belongs to the word called strength. Strength is completely different. In the strength category, we discussed into strong and weak further. But here in the concentration particular classification, there is no use of word called strength and strong and weak. Okay, you know why? Because there is a reason. Because strong acids are strong. Strong acids are strong even in which cases, dilute cases. Dilute in the sense dilute concentrations. Okay, we can write the word dilute concentrations. You know why? Why strong acids are considered dilute, madam? Because you said no, strong is something which means more amount of acid present. So we can say it is a strong acid, right? Can we say like that? Absolutely wrong. Which means strong acids are strong even in dilute concentrations. You know why? What's the reason over here? Yeah, because they produce high amount of H plus ions. Hence the word we can say these are strong even in the dilute concentrations. Okay, then what about weak? What about weak? Yeah, weak acids. Okay, weak acids are weak even in concentrated concentrations. Okay, even in concentrated concentrations, which means they produce less amount of H plus ions. Okay, so based upon this, all strong acids are concentrated acids, all weak acids are dilute acids. There is nothing relation between them like that. Okay, don't confuse and don't do any wrong interpretations. Okay, so here note point to be noted here is concentration is only about concentration is only about concentration is only about concentrated acids and dilute acids. Okay, but here if we do note point, there is no involvement of strength over here. Okay, we should not say all these concentrated acids are strong and all these dilute are weak, because there is a specific classification for strength that is separate, but you should not merge these two. Okay, because strong acids are strong in dilute concentrations. They are strong always because they produce high amount of H plus ions. What about the weak acids? Weak acids are weak everywhere because they produce lower amounts of hydrogen. Yeah, hydrogen ions. Okay, so this is the main classification, and if you observe it, you can understand clearly. Okay, yes. So this is all about the fourth classification. What is the fourth classification, children? Concentration. Based upon concentration means, yeah, amount of acid present, amount of water present in it. Yes. So based upon amount of water present in it, we can classify them into two again: concentrated acids and dilute acids. This is all about the fourth classification based upon concentration. Yeah, if you observe here, there is two: concentrated solution and dilute solution. Okay. Here, if you observe, the particular solution is little bit dark when compared to this. Yes. Okay. So what are these? Yeah, the amount of particles. Okay. There are many, and here if you observe, there are only few. Yes, we can count. And here the definition is more amount of solute dissolved in a certain amount of solvent. Okay, we can write here acid as solute and water as solvent. Because why? Why? Because solvent is present something in watery nature. Yeah, okay. So there is more amount of solute present in less or a certain amount of water, which means solvent. Okay, that is all about concentration, concentrated solution. And what about dilute solution, children? Less amount of solute dissolved, or they do contain certain amount of solvent. Okay, once again, less amount of solute dissolved in certain amount of solvent. Okay, here solute is again acid, solvent is water. Okay, if you observe it clearly, there is a picturization with the concentrated solution and dilute solution. Here we have more amount of acid, less amount of water. Okay, clear? Here we have less amount of acid mixed with more amount of water. Very good. And here they use the terms like this, which means, okay, acid is solute. Okay, also we can write like this. Here acid is considered as solute, where water is considered as solvent. Clear? Okay, more amount of solute dissolved in certain amount of solvent. Here less amount of solute dissolved in certain amount of solvent. Okay, clear, children? Which means the concentrated solution contain more amount of acid with less amount of water. Dilute means less amount of acid combined with more amount of water. Okay, this is all about the concentration and the particular picturization, children. Basicity. Okay, fifth one is based upon basicity. What is this basicity classification? Okay, simple. If I derive this, it is very simple, children, and it is written with the statement, okay, where the number of H plus ions liberated, the number of H plus ions. So what is H plus ions, children? Very good. Hydrogen ions liberated by one molecule. We can write like this also, based upon the basicity, no, which means the number of H plus ions liberated by one molecule is all about the basicity. We'll see what is that now. Based upon the basicity, the particular acid concentration is also divided into three again, namely monobasic, based upon first one monobasic acids, and second one is dibasic acids, and the third one is tribasic acids. What is the third one, children? Tribasic acids. What's the first one? Monobasic acids. Second one, dibasic acids, and third one is tribasic acids. So what is the meaning of mono? 1. Very good. What is the meaning of di? 2. Very good. Tri? Yes, superb. 3. So here I give the statement like this. The number of H plus ions liberated by one molecule. Yeah, one molecule. Based upon that, you can classify easily. Mono means which contain only one H plus ion. Very good. So these which liberate one H plus ions are called as monobasic acids. One H plus only. Fine. Okay. What about dibasic acids? They liberate two H plus ions, are called as dibasic acids. What about tribasic acids? Simple, na? Which liberate 3 H plus ions are called as tribasic acids. There is also another name for these three, are also called as monoprotic acids. What is this? Monoprotic acids. Here it is diprotic acids, and here it is triprotic acid. These are the other names, children. Okay, that's it. These are the other names for this monobasic, dibasic, and tribasic. Namely, what are these? Monoprotic acids, diprotic acids, and triprotic acids. Very good. Come with examples now. Examples here include which contain only one hydrogen. No? You should liberate only one H plus ions in, by one molecule. That's it. So here it is HF, It liberates only one H plus, right? Yeah, very good. And HCl we can write. Yeah, hydrofluoric acid and hydrochloric acids are examples of monobasic acids, or also called as monoprotic acids. Very good. Here it is di, which means it should contain 2 H plus ions liberated by one molecule. We can write H2SO4. Can I write? Yeah, sulfuric acid and any other? Any other children? H2CO3? Because they do contain how many? 2 hydrogens. What about here? 1 hydrogen. Very good. Clear? Now what about this? Triprotic acids or tribasic acid can contain? It should contain 3 H plus ions. We can write here is H3PO4. Okay, phosphoric acid, which means this will contain 3 H plus ions liberated by one molecule. So this is all about simple classification of based upon the basicity, which means number of H plus ions liberated by one molecule. Okay, that is again classified into 3: monobasic, dibasic, tribasic, also called as monoprotic, diprotic and triprotic, namely. Clear? The examples and all. This is easier classification to remember, children. Okay. So moving to next is based upon volatility. Very good. Sixth classification based upon volatility. Okay. So what is this? We'll see now. So based upon the classification of an acid, the sixth classification is based upon volatility, and in this particular volatility consideration we have again into 2 classifications. Okay. The first one is volatile acids. The first one is volatile acids, and the second classification is non-volatile acids. What second classification? Non-volatile acids. What is the meaning of volatile now? What is the meaning of volatile? You know, volatile means something which vaporizes easily, evaporates easily. Yeah. It's based upon, we can say vaporization, or else we can include here. No worry. Okay. Here I'll write it down for you. Okay. So what are volatile acids? The acids which evaporate easily, are called as volatile acids. Once again, what are volatile acids? The acids which evaporate easily at room temperature are called as volatile acids. Once again, children, those acids which evaporate easily. You know evaporation? It goes up, it again changes its state, no? From the liquid or solid to gaseous form. Yeah, very good. So those acids which evaporate easily at room temperature without any involvement of heating or boiling or any other thing, it evaporates easily at the room temperature. So those acids are called as volatile acids. Clear enough? So coming to next is non-volatile, which means they do not evaporate easily, are called as non-volatile. Very good. This is something completely different. Okay, quite opposite. What is here? Do not evaporate easily at room temperature are called as non-volatile acids. Once again, those acids which do not evaporate easily are called as non-volatile acids at room temperature. Okay. Here we go with examples. Coming to the examples of volatile and non-volatile. These examples include, okay, HCl. What is HCl? Hydrochloric acid, and involving with again one more. It is let's say H2CO3. Carbonic acid. Okay, this is also a volatile acid. And here examples for non-volatile acids include H2SO4. What H2SO4, children? Sulfuric acid. Very good. And we can write H3PO4. Phosphoric acid. Yeah, fine. These are examples of volatile acids and non-volatile acids as well. What's a volatile acid now? Which evaporates easily at room temperature. Which do not evaporate easily at room temperature called as non-volatile acids. Okay, examples here we go with HCl, hydrochloric acid and H2CO3, carbonic acid. Okay, here examples: sulfuric acid H2SO4 and phosphoric acid H3PO4. Clear, children? This is all about volatility. And if you see the picturization here, okay, we have something for you. Okay, volatile definition in chemistry. What is that? A volatile substance is one which readily vaporizes, which means evaporates easily. Clear? Okay. So if you see picturization here, the first one beaker containing some blue color liquid and also with some yellow color molecules as well. Okay, here it is, some yellow color one which contains, the particular molecules. You can see in light green. Okay, fine, no problem. Okay, so here if you see the particular volatile, which means they are evaporating easily into the atmosphere, which means they are considered as volatile acids. Okay, here if you see any particular vaporization here, can you observe any particles are vaporizing easily at room temperature? No, right? So these are considered as non-volatile, which means they do not evaporate easily at room temperature. Okay, and here volatile, which means they do evaporate easily at room temperature, called as volatile and non-volatile. Here it is differentiation, children, and here you can observe one more statement. A volatile substance typically has a lower boiling point and high vapor pressure. Hence the reason they'll evaporate easily. Because why? Those volatile substances which have low boiling point and they have high vapor pressure. Okay, because of that reason they do have particular volatility nature, which means they evaporate easily at room temperature. This is all about the volatility, which means the 6 particular classification of acid. So coming to next, last one is based upon the state. Okay, what is 7th classification? Based upon the state. We know states of matter which do exist in 3. What are they? The physical states of matter. What are they? Come on. Yes, solids. Yes, very good. Solids. Solids. One more. Liquids. Okay. Any other, children? Do you remember? Very good. Gases. Okay. So here in this sub-classification, we have the 7th classification of acid based upon state, right? So we also have considerations of solids, liquids and gases, and yes, a few examples are also included. Solids in the sense they have, the solid definitions are not required here. If you see examples, you can happily clearly classify them as a solid or liquid or gaseous acids. Okay. So solids in the sense they have the particular, for example, malic acid present in apple, citric acid present in lemon and orange as well. So all those are considered as solids, solid acids, and liquid, as we'll see the picture is here. Okay, don't worry about this. Okay, here we have the picture on the basis of state. Clearly on the basis of state we have the following. So solids acid include here phosphoric acid H3PO4 and boric acid H3BO3. So we can also include some of the organic acids such as citric acid, malic acid in this category. What is that category? Solids category. Okay, we can also include citric acid and malic acid. All these are, solid acids, right? They do produce the organic one. Okay, very good. So coming next is liquid acids which are present in liquid form, such as hydrochloric acid HCl, sulfuric acid H2SO4, nitric acid HNO3. Okay, these are the based on the state, which means solids, liquids and gaseous nature, right? So we also have, okay, 2 is included, fine. Solids and liquids are very fine for you. And we also have gaseous, aqueous and other things that is required, not required much. Okay, fine. So this is all about the classification of acids, children, based upon the source. Come on, namely first one, source, molecular composition, strength, concentration, next basicity, volatility, and based upon the last one, state. These all are the classifications of acid. Hope you clearly understood about the concentrations and their strengths and their ionizations, everything clear, right? This is all about the acid concentration and acid classifications. Okay, this is all about the classification of acids, children. So hope you clearly understood what about every acid, every classification in detail. so that you can happily do with the worksheet bits and all. Okay. Fine, children, this is all about the classification of acids session, and hope you all clear with all the 7 classifications. What are namely? First one is source, molecular composition, strength, concentration, basicity, volatility, and the last one is based upon the state. So all these are the 7 main classifications of acids. Hope you liked it, and do follow videos for more concentrated and more interesting clips. Okay. Thank you, children. Have a nice day.